So in this relations chapter, one of the things to look at is going to be, like, what are the relationships between two different things? So analyze tables. The table shows the results of a recent survey in which students were asked about their use of text messaging. The X would be the age of students. The Y would be the percent of students that actually text. Determine the domain and the range. Well, we've already been given the table, but for the heck of it, we could list this vertically, because sometimes when we watch these, when we look at these horizontal tables, it's a little bit more difficult for some people to read. Than if it's set up vertically. So I'm going to say, this is horizontal presentation of the data. Well, this is vertical. And I'm personally more happy when I see it looking like this. You don't have to do that at all. I just thought it might be a nice tip. And since this is a real-world problem, we can look at graphing it. And as we graph it, well, are there any negative values that are coming into play? So there's not. And because of that, when you get a ruler out, and you set up your y-axis, you can do that neat. And then set up your x-axis, either order, and go from there. Now, as I'm looking at students in like the whole range, well, if I did this all the way to 20, that would definitely cover there. But I'd have all of this empty, unused space here because I have nothing from 0 to 10. Now, this isn't a huge leap, so I probably wouldn't overthink it like I'm doing right now. But I'd like you to get your eraser out, and usually you see this on the vertical and not so much on the x-axis. Kind of show a little bit of a jump there. It's kind of like a lightning bolt almost. So that we know that there's some skip in the distance. And as I put the numbers 10 and 20 here, I'm going to have a lot less empty space in my graph. Similarly, on the y-axis, if I go beyond 50 to cover 54 and all the way up to 100, I'm going to have a lot of unused vertical space up here. So it's kind of just a little bit of a compromise. Well, you could go to 60, but I'm looking at this 10, 20, 30, 40, 50. I'm using those lines to take advantage of the increments of 10. I'm setting this from there. And then, yeah, sure, there's 60 right there. So this does set us up nicely. To label these, here's your X. You're going to want to be like the age of students. And then on the Y, you can just put like the percent symbol above your Y axis. And then if you were to really be neat and title this, you'd put like the percent of students who use text messaging as the title of the graph up top. Moving ahead, here's 10, here's 15, 1, 2, 3, 4, 16, 17, 18. And since we're not really using this data for future problems, but we are using it for what conclusions to make, I think it would be good to be neat, but not insanely neat. Okay, so 12 over, I'm up 17. Here's what I'm talking about. 12 over, I'm up 17. 12 over, I'm up 17. So I'm going to graph 12, 17, 13, 30, 14, 34, 15, 45, 16, 46, and then 17, 54. And if we were to connect these, it's not like it would be a perfect linear relationship, not like a perfect connection in that. So when it says, like, what conclusions might you make? Well, before we say conclusions, I think it would be nice to see the domain and the range. And, we're going to list this as 12 to 17-year-olds. You can put some meaning there, You could also just say 12, 13, 14, 15, 16, 17. And then the percent, I guess if we go just really the way they do, we have 17, 30, 34, and I'll let you list all those. Don't do dot, dot, dots, but do rewrite all of those numbers. And as we look at this, what conclusions might we make? We might say, teenagers text more when they get older. Now, we don't know really what's causing all this. So, like, if we wanted to, we could be all fancy. Well, teenagers text when they get older because they purchase cell phones more often. Well, we don't know anything about that. So we can't really infer things that we don't comfortably know. All right, let's make this one an OYO problem, and I'll put just the answer up in 5 seconds. Okay, I'm pausing partially through this just because give you some time to think about it. You didn't have to, but I made it into a table so that way it's like the input of the dogs that are walked drives the pay that she gets. Here's the domain, here's the range. All you're doing is listing those out, and then here's the graph where the dog is the input and the pay is labeled here. And my tick mark went to 10, and then I took half, and then 1, 2, 3, 4, and so on. And then similarly, I was able to use my lines to count up to 50. I'm going to drop these points on here. And as you've probably realized, these are all multiples of 7. So if we were to look at this, these should all, if neatly graphed, all be connected. So if you have this to where one of your points is like down here, I think that means your graph's not neat enough. So go ahead and use that erase tool, and I'm talking like I'm on a computer. Use that pencil eraser and clean that up. I'm scanning through everything that we're supposed to do. Here's the info. Didn't have to do anything except for use that info. We did determine the age, the domain and range, and we did graph it, so we are done with this problem, and that completes this video. Again, it is using relationships for real-world problems, and it looks like as kids got older, they texted more, and it looks like there's a direct relationship between the dogs walked and the pay that she gets.